the idea about graphing, okay? I don't want to spend a whole lot of time on graphing because it is once we do one or two of them, it's the same process over and over and over again, okay? And we're going to use our knowledge about transformations that we spent a lot of time so far this year talking about, and we will continue even through trigonometry talking about transformations, okay? This is one of the functions that we probably have the least amount of experience graphing, if any, but it's not that terrible. If I want to graph something like 3 log base 2 of x minus 1 plus 2, I'm going to go through there real quick and just highlight the transformations. 3 of the transformations. What happens if what happens or what is occurring when you take a function and you multiply the whole thing by a number out front? What does that change or adjust in my parent function? It stretches it or compresses it. In this case, because it's a 3, it's going to stretch it. Which direction? Vertical. So that's going to stretch your y values. Okay, and the stretch is because the y values are going to get multiplied by 3. Okay. If I look at minus 1 here, to the x, before I take the logarithm, okay? So this is like if I had x squared, and then I rewrote it as x minus 1 squared. What does the minus 1 do if I am subtracting from the x before I apply the parent function? It moves it 1 to the right, okay? So x minus 1 there is telling me that we've got a horizontal shift here, okay? If I add 2 to the whole thing, okay, what does that do? Okay, that's a vertical shift moving it up 2 units, okay? So what did I not highlight there? Log base 2 of x, right? So log base 2 of x, the thing that is not, so I go through and I always look at the things that I think kind of clutter the problem, and that's the transformations. If I can identify what all the transformations are, it leaves me with the parent function that I'm really interested in here. Okay? Log base 2 of x. Log base 2 of x is going to be our parent function. Okay? So as we set out on this problem, that's the first thing I'm going to try to understand before I do any transformations. Okay, so we're going to try to set out to graph that first. Okay, and in order to graph a logarithm, we kind of talked about it a little bit yesterday, you're going to use the knowledge that you have about its inverse. What is the logarithm's inverse? An exponential. Okay, so I want to change this to an exponential. And the way we change this to an exponential is that we use this rule. It says log base a of x is equal to y if and only if a to the y equals x. That's the definition of a logarithm. Okay? So we're going to use that along with rules that we talked about a little bit in regard to inverses. There's one rule that when we create an inverse function, what you basically do is you take the function that you want to write the inverse of, okay? You flip the x's and y's, and then you solve for y. That's the overall general procedure for finding inverses. Okay? Most textbooks will tell you to flip the x's and y's first. You can also flip the x's and y's last if you want to. Okay? Right here, I'm just going to flip them first. So let's go ahead and take this red function. Let's flip our x's and y's. So that just means I'm just going to interchange them. So we get something like that. Does that make sense? Okay. Now, I go try to solve for y. Okay. Well, if I'm going to try to solve for y, and y is stuck in the argument here of the logarithm, the way we're going to do that is we're going to apply this rule. Okay, so I'm going to take that raised to the y to come back and give me x so that it turns into that format. Does it make sense? So I'm going to take my base of 2 I'm going to go across the equal sign, and that x becomes my exponent, and it comes back and gives me my argument. See how that gives you out? We now have determined what the inverse of log base 2 of x looks like. The log base 2 of x equals y. Its inverse is 2 of x equals y. Okay? That's an exponential, right? Now what I'm going to do, I'm not going to graph anything yet. We'll graph everything at the end. We know more about the exponential function than we do about the logarithmic function. I know nothing about the logarithmic function at the moment. Okay? But we know there are points, we know some parent function points on y equals 2x. If you remember, the x values that we choose for any exponential are -1, 0, and 1. If I choose 0 as my x value, what is always the y value for the exponential? 1. And if you can't remember that, just plug it into 2 to the x. Okay, 2 to the 0 gives me 1. If I try 1, okay, that just gives me back my base, right? Okay, so we remember from when we worked with exponential functions, we said the point 1 comma a was always on your exponential. Well, a in this case is 2. So we got 1, 2. And then -1 as the x value, that ordered pair on the exponential is always -1 comma 1 over a. So -1, a being 2, so the ordered pair here should be -1 comma 1/2. Does that make sense? So we know that. Okay, that should be something that we've committed to memory and we don't have any issues with. So now what I want to do is I want to write the ordered pairs that should go with y equals log base 2 of x, which is the inverse of y equals 2 dx, right? And if they're inverses, what does that tell me about their domains and ranges? They're flipped. Okay? So if this has the point A comma B on it, then this is going to have the point B comma A, right? That's what the definition of an inverse really is. So if 2 to the x has -1, 1/2 on it, then log base 2 of x is going to have 1/2 -1 on it, isn't it? It's going to have 1, 0. And it's going to have 2, 1. Is that okay with everybody? Okay. So what that does is now gets us 3 points on the parent function log base 2 of x, which is exactly what we were looking at up here in the original problem, right? Now that we know 3 points on log base 2 of x, let's transform those 3 points. Okay? And when we transform 3 points, or any amount of points, even going back to the beginning of chapter 3, we had that acronym. Okay? Well, if we're doing transformations, it's just the safest way of applying your transformations in with the intent of not ever doing a transformation that is dependent on another transformation out of order. Does that make sense? If I always do it that way, dependency will always be abided by. Okay? H stands for horizontal movement, S stands for stretching, R stands for reflecting, and V for vertical movement. Okay? Do them in that order. So do we have a horizontal movement here? Right one, correct? So when this is going to be my final set of ordered pairs here. So this will be x, and these will be 3 log base 2 of x minus 1 plus 2. Okay, so if I'm going to move it right 1 unit because of that minus 1, what does that ordered pair of 1/2 become? That's the x value. You're going to move it right 1 unit. It's going to come 1.5. Am I right? It's 3 halves. What is that one going to become? 2. And that one's going to become 3, right? So the x minus 1 just says you're going to add 1. As you're moving to the right, you're going to add 1 to every one of your x values. If it was x minus 2, you'd add 2. If it was x minus 7, you would add 7. If it was x plus 3, you would subtract 3. Does that make sense? You're moving either left or right and when we're attacking the x value. Okay? Okay. So we did the horizontal movement. Let's do the stretch. The stretch does what? That 3 out there you said was the stretch. What does that do to my, or what ordered pairs does that impact? Or what coordinates, I guess, does that impact? Does it impact the x's or does it impact the y's? The y's, okay? And what am I going to do? I'm going to add 3, subtract 3, multiply 3, divide by 3, multiply by 3. So all of these are going to be turned into the multiple of 3. So negative 3, 0, and 3. And the only thing that I haven't addressed now, we don't have a reflection, so we'll skip that one, is our vertical movement, right? So if I do my vertical movement, that means I'm going to add 2, but what do I add 2 to? What coordinate? The y. So I'll add 2 there, I'll add 2 there, I'll add 2 there. So it's going to give me negative 1, it's going to give me 2, it's going to give me 5, right? So if we plot the points 3 halves, comma negative 1, 2, comma 2, 3, comma 5. Okay? Those should be points that are on our logarithm. Okay? My next question, because there's a little bit more to this. My next question is, what is for this function 2 to the x equals y, what is the asymptote? For any logarithmic function that has not been moved left, right, up, or down, what is the asymptote?
0.
Y equals 0. Okay? If you reflect an asymptote across the line y equals x, that's what we do with inverses, right? What does the line y equals 0 become? If I were to give you y equals 0 and reflect that across the line y equals x. Okay, so take the red line, reflect it over the blue line. And remember, when I reflect over the blue line, another way of visualizing that is fold your graph on that blue line. If I fold my graph on that blue line, this two-dimensional plane, fold it on that blue line, where does this red line right here on the left side of the x-axis, where does that go? You're going to fold this thing right there. May I visualize that? If I fold on the red, or fold on the blue line, doesn't that take points? So let's do it this way. Let's say this point here, that point there, that point there, that point there. If I reflect this red line across the line y equals x, where does the point negative 4, 0 go? It goes to 0, negative 4, right? Does that make sense? Where does negative 2 go? 0, negative 2, right? Where does 2, 0 go? 0, 2. Where does 4, 0 go? 0, 4. Where's that red line going? It's going to become the y-axis. Okay? So when you take a horizontal asymptote and reflect it across the line y equals x, that horizontal asymptote turns into a vertical asymptote. So for our logarithm, we're going to have that purple line being an asymptote. Now, we also, because remember when we shift things, left, right, up, or down, if I shift something up and down, asymptotes get shifted up and down. Horizontal asymptotes get shifted up and down. Does that make sense? If I have vertical asymptotes, and I shift things left and right, the asymptote should be shifted left and right as well. So where is this asymptote? Where should it really go? Instead of x equals 0, it should be X equals 1, because then the whole graph gets shifted to the right 1 unit, because that X minus 1. All right, so the line Y equals X is here, and we'll have that there to kind of convince us that we've done things correctly here in a moment. But if I plot those points, 3 halves, -1 was one of them. 3 halves, -1. We had one that was 2, 2, and we had one that was 3, 5.
What did the R stand for?
The R.
HSRD.
Reflections. So I plot those points. Okay? Those are 3 points, along with my asymptote. Those are 3 points that are going to help me create my logarithm. Okay? We can't go left of that asymptote. Does that make sense? Okay, so we can't cross it. So as I go from this point, this direction, my graph is going to go down. And as I hit B and C, I start to get away from that asymptote. So my graph is going to kind of tail off to the top there. If I graph it, we see the 3 points that we came up with using our algebra concepts are indeed 3 points that are on that curve, right? Okay. So now what I want to do real quick is look at its inverse. Okay, so the inverse of this should be, let's see here. Where's my pens at? Let's use our, and I'm not going to make you do this, but this maybe could generate an alternative way of doing what we just did. If I take this and apply our logarithm definition that says log base A of X equals Y if and only if A to the Y equals X, okay? Right here is my base. So I'm going to take, so this here in green is that side right there of our definition. I'm going to take that base and I'm going to raise it over here to that. Okay? So 2 raised to the y, essentially, is equal then to that. So x minus 1 plus 2. Still got my 3 here. Actually, let's not do it this way. I don't like doing it that way. Let's do it this way. It'd be quicker. So I'm not going to make you, the way that I just asked you to graph it is the way that is the quickest. I just want to validate, I want to confirm to you that right there, the points that are on there should be, so that should be my, I was hoping it would give it to me in the exponential form. Well, can't change it? No. This is the inverse of that logarithm, okay? So if you're a person that prefers to maybe graph the exponential completely first, okay? You would get this and then take these points off of it and find their, just flip their A's and B's and it'll give you those as well. I don't know if that's the best route or not. Does it make sense on what we did here? Okay, if we can do that, that's what my goal for you is at the moment. Okay, be able to realize that if I've got log base 2 of x, then its inverse is 2 to the x equals y. If I've got log base 3 of x, then the inverse is 3 to the x equals y. Okay, so find the exponential, find its ordered pairs, and then flip them to find the ordered pairs then of the logarithm, and then adjust them depending on what the transformations are. Okay. On Monday, Tuesday, and Wednesday of next week, we are going to get into the natural logarithm. Did you guys do anything like last year where we had like log base 3 of like 4x, and you can rewrite that as log base 3 Log base 3 of 4 plus log base 3 of x. Those are the same thing. Did you guys do any of that last year? Okay. We're going to do a little bit of that hopefully on Monday. And then Tuesday and Wednesday, I want to teach you how to solve logarithmic and exponential equations. Okay? Which will be kind of a shortened down, modified activity. Okay, so it's not going to be what we would normally do in an elongated college algebra course. We've kind of been hamstringed here with the technology issues and that kind of stuff. Slows us down a little bit. The 2-hour delays every day slows us down, right? So we haven't had the same time frame that we've had in the past, and that kind of messed our schedule up. If we have time, I think we will with trig. And we don't fully get what we need next week out of solving logarithmic and exponential equations. We can take a couple days out of the trig course to do that.
Hey, are there test dates, or is there final?